This is the video on the math quiz. I'm gonna do the last three problems on the quiz. So number 4, if you dilute 175 milliliters of 1.6 molar solution of lithium chloride to 1 liters, determine the new concentration. Concentration is the same thing as molarity. So we have three different solutions that we're thinking about here. We have the first one, which is the 175 milliliters, or 0.175 liters of a 1.6 molar solution. And we're diluting that to 1 liter, and we're trying to figure out what the new molarity is. So when we say we're diluting it, it means that we're adding water to it. So I could have asked how much water did you add, and you could have easily done that by doing 1 liter minus 0.175 liters, but I really didn't need that. So we're pouring in enough water to make it up to 1 liter, and we're pouring in all of the 1.6 molar solution. As soon as you see the 1.6 molar, first thing we do is write a for every statement. For every 1.6 moles, there are 1 liter. That's just another way of writing 1.6 molarity. For every 1.6 moles of lithium chloride, there are 1 liter. So this is the first solution that we're worried about. And we would have known that if we did the drawing. Now in our drawing, we don't have 1 liter. We have 0.175 liters. So we need to figure out how many moles are there in this solution. Because if we figure out how many moles there are, and we're dumping the entire solution into this third solution, then once we know the moles, we can figure out the molarity of that third solution. So let's figure out how many moles there are. So this 1 liter is actually 0.175 liters. And in order to do that, we're dividing by 5.7. So we would do the same thing here, 5.7. And what we should get is 0.28 moles. So in this solution right here, 1.6 molar, 175 milliliters, there's 0.28 moles in here. Now if we dump the entire thing into this solution over here, that means there's 0.28 moles in there as well. And we're trying to figure out is the molarity. So let's write down the information that we have for this solution in a for every statement. So we know how many moles there are. So for every 0.28 moles of lithium chloride, there are, from the problem itself, we know 1 liter. And I gave you guys a freebie here because whenever you see a for every statement that involves moles and liters, and you have 1 liter, this is another way of writing the molarity equation itself, in which case the number of moles is actually the molarity. So the molarity for this solution that we ended up with should have been 0.28. Number 5 is another dilution problem. Now, so it says you need to make 10 liters of 1.2 molar potassium nitrate. So it's saying that we need to make that much. So it's not that, the first solution. This is the water, and it's not that. So it's this third solution. And it's saying you need to make 10 liters of a 1.2 molar solution. So what molarity would the potassium nitrate solution, the first one, need to be if you were to use only 2.5 liters of it. So it's telling us that we're using only 2.5 liters of the first solution, and it's asking us what is the molarity. Now, if we have 2.5 liters of that first solution and we're getting to 10 liters, we can pretty much figure out what we used for the water. So it should be 7.5 liters of that. So we use that much water, and you have to remember that water does not contribute anything in terms of molarity, and it does not contribute anything in terms of moles. So when I say it doesn't contribute anything in terms of molarity, we're not worried about the molarity of water, and we're not worried about the moles of water. So whatever moles we find, there's only one place that it could be, in this solution. And whatever moles we have there, if we're dumping the entire thing in it, then it's going to be right there. So the moles between those two solutions, those moles should be the same, and that's what we're using here. So first step, you need to make 10 liters of 1.2 molar potassium nitrate. If we can figure out the number of moles in the solution, then we sort of figured out how many moles are in this solution. And if we figured out the moles in that solution, and we know how many liters we have of it, we can figure out what the molarity of that first solution is. And that's basically what the question is asking us. So first thing we do when we see a molarity like that, we write a for every statement. And another way of writing 1.2 molarity is to say that for every 1.2 moles of solute or potassium nitrate, there are 1 liter of solution. But in this case, we don't have 1 liter of solution. We have 10 liters of solution. So we're multiplying by 10. So that means in this third solution, there are 12 moles of potassium nitrate. Now, those 12 moles could have only come from one place, this first solution. So now we know how many moles there are in that first solution. And if we know the number of moles and the amount of liters, we can figure out the molarity. So let's write down what information we have over there. So we know the number of moles, which is 12. So for every 12 moles, there are 2.5 liters. So the first for every statement is just writing what we have in that particular solution. 12 moles and 2.5 liters. We still didn't get the molarity though. In order to get the molarity, we need to have a for every statement that is so many moles per 1 liter. So we need to get this down to 1 liter. So we're dividing by 2.5, and if we were to divide 12 by 2.5, we should get 4.8 moles per 1 liter. When we have a for every statement that ends in this per 1 liter, what we have for the moles is actually the molarity itself. So this molarity is the concentration or molarity of that first solution that we used 2.5 liters of to make this final solution. So the answer is 4.8 molarity. The final dilution problem on the quiz, number 6. How much 2 molar sodium chloride solution would you need to make 250 milliliters of 0.15 molar sodium chloride solution? So we're asking how much of this we need to make a final product of that. So we have a first solution, and right now all we know about it is the 2 molar. We have a second solution, which is just water. And our third solution, which is the final product. And based off of this right here, we know what it is. That it's 0.250 liters, and it's 0.15 molarity. So if we have these pieces of information, they're asking us how much of this solution was used, meaning how much of this total solution was poured in there, along with a certain amount of water to get this much molarity and this much liters. So first thing we do, if we can figure out the number of moles in this solution, we know exactly where they came from this solution. So if we know the moles from that solution, we can figure out how much of that solution we had to use to get this final product. So we have a molarity, so we already have a for every statement. For every 0.15 moles, there are 1 liter of solution. That's just another way of writing 0.15 molarity. But we don't have 1 liter. We have 0.250 liters. So if it's 0.250 liters, we're dividing by 4. And if we were to divide the moles by 4, we should get 0.038 moles. So that means that there's 0.038 moles in this solution. It could have only come from one place, the first solution. So now we know how many moles there are in that solution. And the question is asking us, how much of it did we use? Well, we can figure that out because now we know the moles and we know the molarity. So because we know the molarity, that's the first for every statement. For every 2 moles, there are 1 liter. That's just another way of writing 2 molarity. We don't know how many liters we have just yet, but we do know how many moles we have. That much. We don't have 2. We have 0.038 moles. In order to get that, we're dividing by 52. And if we were to divide 1 by 52, we get 0.019 for the liters. So that is how much of this first solution we have to use to get this final product. And I could have asked you how much of water we had to use, and that would have been simple. If you have a total of 0.250 liters and you know how much you're using, you just subtract the 2 and you can figure out how much of the water you used as well. So the answer for this, we used 0.019 liters of that 2 molar solution to make that final product.